So our first one here, C3H6 plus O2. So in this case, we have a compound plus an element, but the key part here is what is the element? The element is oxygen. So since the element is oxygen here, oxygen plus a compound is going to be an oxidation reaction. C3H6 is a hydrocarbon, and so that makes this one easy. We know that this is oxidation and hydrocarbon, so it's going to be just CO2 plus H2O is what we get for our products. Now we have to balance it. We have 3 carbons on the left and 1 on the right, so we put a 3 up here. We have 6 hydrogens on the left and 2 on the right. We put a 3 right there. And doing this, oxygens, we have 2 on the left. On the right, we have 6 that's right here, and then 3 that's right here gives us 9. But 9 and 2 don't work. We're going to have to go up a step. We're going to have to double what we've got here. And so we're looking for the least common multiple between 9 and 2, and that's 18. So we're going to have to put a 9 out here to make this 18. And in doing that, we have to double everything else that we had before. And so that means we have to erase some stuff in here. See if we can do it without messing up everything else. We have 18, which means that we're going to have, instead of having 3 carbons out here, we're going to have 6 to start with right here. And instead of having 3 out there, we're going to have 6 right here. And so if we do this, then now, make sure that I'm working this out right, we have 9 times 2 gives us 18 over here. We have a total of 6 times 2, which gives us 12 carbons on this side. 6 times 1, I'm sorry, 6 times 1 gives us 6 on this side. 12 plus 6 gives us 18, and then 9 times 2 gives us 18, and so that works out. Now, we do now have to change our carbons. We have on the right side 6 carbons now. We have on the left side just 3, so we put a 2 out front. Now, that gives us 2 times 6, 12 hydrogens on the left. And we have 6 times 2, 12 hydrogens on the right. And so this balances out. And so as you can see, these oxidation or combustion reactions can get complex pretty quickly. And so that's basically how you work that one out. And that's what we'd get for that particular combustion reaction. Let's take a look at the next one. Na plus N2. Element plus element. Whenever you see element plus element, you think synthesis. And so with a synthesis reaction, we're simply combining these two. And so we have Na and N that are going together. Na, sodium, has a valence of +1. Nitrogen here is an anion, and when it's an anion, it has a valence of -3. And so this has to be Na3N to work this out. Now, if we take a look at to balance the whole equation, is we have 1 sodium on the left and 3 on the right, so we put a 3 out front. We have 2 nitrogens on the left and only 1 on the right, so we have to put a 2 out front of that. But that then changes the number of sodium. Now we have 6 sodiums on the right, and so we are going to change our front. Oh, I don't know what I just did there. Should be 6 on the right over there, but give me just a second while I see if I can modify what I just undo what I did here. Boop, boop, boop. I went to the wrong one entirely. I don't know how I did that. Give me just a second as I pause this, and I'll be back in just a second. So continuing there, we have, to get this to work, we said that we've got 2 Na3N. We have 2 N's on the left and 2 N's on the right. For NAs, we have 1 Na on the left and now 6 on the right. So we have to put a 6 right here, and that balances that guy out. On our next one, we have SnOH4. And so we notice we just have 1 reactant. That tells us it's going to be a decomposition reaction. We say how many elements it have. It has 10 and oxygen and hydrogen. That's 3, so it's a ternary decomposition. If it's ternary, we're going to make sure we see which one is it. Is it acid, hydroxide, carbonate, or chlorate? And so is it an acid? Nope, doesn't start with hydrogen. Is it a hydroxide? Yes, it has an OH sitting right down in there. And so that's going to tell us it's hydroxide. And if you look at your color sheet, your predicting reaction product sheet, you see hydroxides are going to they decompose to form water and the metal oxide. And so the first piece that's right here is going to be water. And so we have H2O plus, it says next it's going to form, we said, the metal oxide. The metal here is going to be tin. SN. So we have SN and O. Now, what valence does it have? We look at tin on there, and tin is either +2 or +4. So we have to figure out which one it is. And we know hydroxide is -1. And so since we have 4 hydroxides, that means the total valence is -4, which means the tin has to be +4. So this is tin 4 oxide over here on the right. Since oxygen is -2, to balance out the 4, it has to be SnO2. And so these would be the products, water and tin 4 oxide. And now to balance the rest of it, we're going to make sure we look and we have 1 tin on the left and 1 tin on the right. We have 4 oxygens on the left, and right now we only have 3 on the right. That one's a little bit difficult to balance though because we have oxygens 2 different places. So let's look at the hydrogen first. We have on the left 4 hydrogens, and we have 2 on the right. So we can put a 2 right here. That gives us 4 hydrogens. That, notice, also changes our number of oxygens. Now on the right we have 2 times 1 is 2 plus 2 that's over there, and so that gives a total of 4. And sure enough, we have 4 on the left, and so this balances out. And so that would be that decomposition problem. Our next one, H2SO4 plus MgClO in parentheses 2. Sulfuric acid plus magnesium hypochlorite. And so in this case, it's compound plus compound. This is going to be a double displacement reaction. They're just going to switch spots on us. And so that means that the cation on the first one wants to go with the anion on the second one, and the cation on the second one wants to go with the anion on the first one. And so to do this, we're going to end up having hydrogen and the hypochlorite, ClO. Now, hydrogen has a valence of +1. Hypochlorite has a valence of -1, so that just balances out nicely. Don't have to do anything to it. Our next one is going to be, our cation is magnesium. Our anion is sulfate, SO4. Magnesium has a valence of +2. Sulfate has a valence of -2. So that one balances without any trouble there. Now we have to balance the whole equation. We have 2 hydrogens on the left and 1 on the right, so we put a 2 out front. We have 1, so in this case the sulfate, the polyatomic ion right here, stays in one place. So we can just treat this like one whole piece. And so we have 1 sulfate that's over on the left, and we have 1 sulfate on the right, so that works. Magnesium, we have 1 on the left and 1 on the right. Hypochlorite, once again, it stays as a whole piece here. And so there are 2 on the left and sure enough 2 on the right. And so this would be our final balancing here. H2SO4 plus MgClO2 yields 2HClO plus MgSO4.